So a project is about Android master key code signing vulnerability. A group number is GROUP6 and a group members are BISHWA, KHOZAIMA and Minhan. So what's happening here? We are exploiting the vulnerability in the verification and the installation process of an Android application to gain system access, at the same time maintain the original signing certificate. To understand this, we need to understand the basic APK or the zip file structure. As you can see, that the first 4 blocks contain the files. The last block contains the central directory, which is of our concern. The central directory contains a lot of metadata, amongst which manifest.mf and classes.dex are the files that we need to consider. So the manifest.mf file, the manifest.mf file will contain the hash of each of the files in the zip file. The SF block will contain the hash of each of the files in the manifest.mf block, and the RSA will contain the hash content. The signed hash in the RSA will contain the hash content of each of the file in the SF block. During the Java verification process, the hash of the manifest needs to match with the file in the zip. Files in the APK or the zip file. The hash of the SF block needs to match with that in the manifest block, and again the hash and the signed hash of the RSA needs to match with the hash of the SF block. Only then we'll have a successful verification. So we tried inserting a file in the zip file, and as you can see that it did not go through the verification process, and the manifest.mf had no hash for the file 5 that we tried inserting. So during the Android application installation process, the 2 main stages that we encounter is a Java verifier and the C++ parsing. The Java verifier has this function called the linked hash map function, which will verify the hash content of each of the files with that in the manifest or the central directory. So what the Java verifier does, that it always points towards the last duplicate name encountered. It will not consider if there are 2 files with the same name. It will always consider the second file. And the C++ comes into picture when the installation process starts. It allows duplicate entries, and if we have 2 files with the same name, it will always consider the first file which comes into execution, which it encounters basically. So we tried doing that, and as you can see that we've inserted 2 files with the same name, classes file 4. So this will successfully pass through the Java verification, since Java will encounter the second file and it will pass it to the C++ installation. The next what we do is we insert a good file 4 and a bad file 4, that is the good and the bad code. No installation takes place over here, no verification takes place over here, since the Java verifier encounters the bad code and there is no installation. But in case if we enter the bad code first and then the good code, the Java verifier successfully verifies this and it passes this to the C++ installation stage. That is the C++ parsing stage. The C++ again will successfully install this particular structure, because as I mentioned earlier, C++ always encounters and executes the first file. So in this case it will never go to the good code. The bad code will come into picture and C++ installs it. So to demonstrate this exploit, we've used the Cisco AnyConnect application. The main reason for using this application was because it has all the system privileges, and so what we did first is we tried getting the APK of the Cisco AnyConnect application. As soon as we get the APK, we unzip the APK to get the classes.dex file. The classes.dex file is then we disassemble using the APK tools. So as you can see here, the Android manifest.xml file gives the details of all the permissions that we have for the Cisco AnyConnect application. So now the disassembly of the classes.dex file gives you you can get two kind of codes, either the Java code or the Smalley code. The Java code can be viewed in the Java application, but you cannot edit that. So you need to have the Smalley code to make any modifications. So this is the function, this is the command which you can use to get the Java code for the classes.dex. So you can see the dex2jar command, and the corresponding Java code that we've obtained. The same code we are viewing it in the Java application, and on the left you can see that there's a primary activity. This activity is the activity which gets executed first when the application starts running. So yeah, so the main concern in the primary activity would be the onCreate function, which is used to modify our code. So this is the onCreate function is the function where we'll be injecting our evil code. So how do we get this evil code? We built two new Java applications. Basically, this is the Hello World application. We build it, and one application is with the good code, and the second one is with the evil code. Once these applications are successfully built, we again the one thing that we need to consider is that we need to consider that Java applications that we just built should match the version with the Java application that we are exploiting. In this case, the Cisco AnyConnect application should have the same Java version as that of the new applications we just built. So yeah, we disassemble these two APKs, the new Java codes, and we view the evil code of the Java. We view the evil code, and you can see that over here we view the disassembly of the evil code. So this is the disassembly of the evil code, which is illustrated in the picture. So we need to make a few modifications before we can use the same for a Cisco AnyConnect application. So the two modifications that we need to make here is the .line 18. We replace that to hash patches start so that the APK can execute that. And the second thing that we need to do is we need to replace this path name, the path with the path of our Cisco AnyConnect application. So yeah, this is a short description of what we are doing, and this you can see the hash patches start and hash patches end, which we are replacing for the Cisco AnyConnect application. So now using APK tool, we are building the new Cisco AnyConnect application with the same name. So this application that we are building has the evil code now. So once the application is built, we unzip it and obtain the classes.dex. This classes.dex is renamed to classes.dey. So now classes.dex, that is the good code, classes.dey, the evil code, and the original Cisco AnyConnect APK are all placed in one directory. So now this is the procedure that I just mentioned earlier. What we do is from the original APK we delete the classes.dex file. So we are deleting the .dex file, and here you can see there is no classes.dex file now. We insert the classes.dey file. You can see the commands on the screen here, and once we insert the classes.dey file, we insert the classes.dex file again, the original code, and this successfully passes installation, and first passes verification and then passes installation, and this is how we exploit the vulnerability. Thank you.